Well, shalom, my friends. This is the day, the great day that Yah hath made. And in this video, we're finally going to get down to the nitty gritty. Is this earth flat or is it a globe? We're going to be looking at what the Bible scriptures has to say, of course. And we're also going to be looking at the empirical evidence that science found in their early days up until now that they have so kindly covered up and kept secret. All right. So let us start in 1 Corinthians chapter 16, verse 30. So we're going to see what Yah thinks he did with this earth. We're going to see how Yah thinks he made this earth. But of course, people, they think they know better than the Most High. They think he don't exist, just a product of fiction. So we're going to quickly disprove that in this video. And bear with me, this is going to be a nice, meaty, long video because there's tons of information and evidence to support our claim here. So right here in verse 30 of chapter 16 in 1 Corinthians, it says, "Bow yourself to Yah in his splendor of his holiness." Bow yourself to Yah in the splendor of holiness. "Tremble before him, all the earth. The world is firmly established, immovable." So right there in our first verse of the day, Yah lets us know that the world he made is firmly established and immovable. And let's also go to some other verses here. So we got so we also have in the book of Psalms, let's do 96. Chapter 96, verse 5. Sorry, chapter 96, verse 10. It says, "Tremble before him, all the earth, declare among the nations, Yah is king. The world will surely steadfast, never to be shaken." So another verse that lets us know we ain't moving and that the earth is firmly founded. Let's go to another Bible verse. Still in the book of Psalms, chapter 104, verse 5. It says, "You fixed the earth on its foundations, so it can never be shaken." And look at those words. You fixed the earth. You fixed it, meaning it is not moving. It's supported up by the pillars of heaven that the Bible speaks about. It says you fixed the earth on its foundations, so it can never be shaken. All right. So those are a few Bible verses, and as we go along in this video, and as we uncover more information, we'll be doing some more Bible videos to support our claim. And of course, we're going to have tons of scientific evidence because there's a lot of people that think science is just completely against it, and science has shown no proof of the world being firmly established and all this crap. So we're going to do this first. We're going to start with our first scientist of the day named Dominic Orrego. And we're going to have many more too. Dominic Orrego. Now he's a scientist from the early 1800s, all right? And what Dominic Orrego did, he took a telescope, right? So he came up with the hypothesis that if the Earth is moving on a diameter of 187 miles around the sun, if he fixed his telescope on a star, he thought that he would need to change the focus of the star as the Earth moves away, because as you know, 187 mile diameter around the sun is very big. So there would be a considerable distance being shown if he found what he was looking for. So what he did this test for a year. So notice that he did this for a long time, this test for a year, Dominic Orrego. So he came up with the idea again that if he had his telescope fixed on a certain star that as the year went by, he would need to switch the focus and zoom closer to the star because as we move on this 187-mile diameter around the sun, we be getting further away from the stars as we rotate, right? So when he did this test for a whole year, he found out actually that he indeed did not need to change the focus on it. And this could be compared to with a camera. And say you're taking a picture of a person, if they're right in front of you, you don't need to zoom in or out. But if they move away, if they move 30 feet away, you would need to zoom in because they moved away. That you would need to zoom in to get the same clear picture you're looking for. So that's what he was thinking what he would need to do. But he actually found out that he did not need to change the focus of his telescope over the year, proving that the Earth was not moving away from the stars. But of course, that's just the first one. Don't worry. This video gonna get real good. It's gonna get real better. So now let's look at our next scientist of the day named George Biddle Airy. Alright? So right here, George Biddle Airy is this man here, and he was an astronomer. He was an astronomer and mathematician. So George Biddle Airy, George Biddle Airy came up with this test with two telescopes, right? And he did this in the 1840s. He did this in the 1840s. So what George Airy did, he put two telescopes side by side, one filled with air and the other with water. So the hypothesis for this test was if the Earth is moving around the sun at 66,000 miles an hour, 19.5 miles a second. That's very fast. And of course, we don't feel ourselves moving at 19.5 miles a second because it ain't so, which we will be quickly learning. So he proposed if the light coming from the star hits the water-filled telescope, he would need to lower the telescope to the bottom of the star to catch the full light rays. And an example of that would be like when it's raining and you have an umbrella and you're standing still. The rain, which would be our light, in this instance, is coming straight down on you because one, you're not moving, so you don't have to tilt your umbrella or the telescope. You don't have to tilt your umbrella. But if you start moving, if you start running, the rain is still coming down straight. The rain is still coming down on this straight path. But because you're moving against the light, the rain would be coming down in a diagonal. I'm sure we've noticed this, like when you run through the rain and the water starts to hit your pants or your feet, and you have to tilt your umbrella so that you don't get wet up. So that's the example we can use to see how his telescope light theory was supposed to work with the starlight. So what he was saying is if the Earth is moving around 66,000 miles an hour, once the light goes through the water-filled telescope, he would need to tilt it because light travels slower through water. If you didn't know that, light travels slower through water. So he would need to tilt it because the Earth is moving. So as the Earth is moving against the ether, and the ether would be the light coming from the stars. The ether would be the light coming from the stars. And if the Earth is moving against the ether, as the light travels, he would need to adjust his telescope to catch as the Earth travels. He would need to adjust the telescope because the light coming into the water-filled telescope is slowing down, so it would naturally hit the side of the telescope, right? So what he ended up finding out was that he did not need to do that. He ended up finding out that the light coming from the stars was aiming straight down and going straight into the islands of the telescope. And he actually did not need to tilt the telescope. And here's a quick little demonstration video of how this was working. All right, so hold on.
If a telescope is pointing at a star and both are stationary, then obviously the light comes straight into the telescope. In 1729, Bradley found that he had to tip his telescope forward very slightly to get a star in the center of his telescope. It was assumed that this was due to the motion of the Earth around the Sun. Let us assume that the telescope was moving at 5 miles an hour and had to be tipped 5 degrees. This 5-degree tipping, however, could equally be caused by the ether moving at 5 miles an hour, carrying the stars around the Earth. As we see here, the light would be coming in at the same angle and the telescope would still have to be tipped 5 degrees. So tipping the telescope does not tell us whether it is the starlight moving or the telescope moving. However, there is a simple experiment that can determine whether it was the Earth that was moving or the ether and starlight. All that you had to do was record the tipping required for any particular star, then fill the telescope with water, which greatly slows down the speed of light in the telescope. So here is the moving telescope filled with water, tipped at 5 degrees, and you can see that the starlight does not now reach the eyepiece at the bottom. This is because the starlight moves much more slowly when passing through water. However, if the telescope is tipped further, say 10 degrees, then the starlight will then be visible again in the eyepiece. It has to be tipped further because the light is now slower when in the telescope. But if the starlight is going past the telescope at 5 miles an hour, then when it is filled with water, no further tipping is needed because the light is coming in at 5 degrees anyway. The starlight stays on the same path but is only travelling slower in the water. To recap, if it is the telescope that is moving, then when it is filled with water, it has to be tipped further to see the star. If the telescope is stationary and the starlight drifting past us, then it does not have to be tipped further. In 1871, George Biddle Airy, the Astronomer Royal, performed this experiment. This is a copy from his original report. You can see that the two readings are virtually identical. If it had been the telescope that was moving, Airy expected a figure of 30 seconds of arc. In fact, he only managed to read 0.8 seconds of arc difference. Bradley first discovered stellar aberration, and it is interesting that in his report Airy mentions that it was now about 100 seconds of arc and that it was still slowly diminishing. This indicates that the speed of light was still decreasing in measurable amounts when Airy performed his experiment in 1871. The result of Airy's experiment, known as Airy's failure, was that the telescope does not have to be tipped further. This proved that it was the incoming light that was moving past a stationary telescope fixed to the stationary Earth. What is interesting in his very brief report of only 4 pages is that not once did he refer to the astonishing results that the experiment proved, that the Earth was stationary. This experiment was also dismissed by Wikipedia, which said, "Ether drag test," under the main article, "Luminiferous Ether." By means of a water-filled telescope, Airy in 1871 looked for a change in stellar aberration through the refracting water due to an ether drag. Like in all other ether drift experiments, he obtained a negative result. This is a gross distortion of the truth. That he did not have to change the angle proved that it was the ether drifting past the stationary surface of the Earth. This experiment is never taught to university science students. They might begin to question what they were being taught about the cosmos, the universe, the Big Bang, evolution, and much else, if it was realized that the Earth really is at the center of the universe, which is rotating around us, as the Bible always clearly states.
Now, isn't that just amazing? So now we have two scientists. See, George Airy, he was trying to disprove what Dominic Orrego found. So he made it more sophisticated. But of course, he ended up finding out, dang, there is no movement under the stars. Because both light because the starlight was coming in to both telescopes at the same time, the water-filled telescope and the air-filled telescope. It's just that when it went through the water-filled telescope, the light slowed down, but it still went straight to the eyepiece lens. So pretty much what he was able to conclude in layman's term was that the starlight has the same infraction and it shoots straight down into the eye of the lens, proving that the stars are proving that there is no movement under the stars. The light is far enough away that no matter where you are on the earth with a telescope, the starlight shoots straight into the eyepiece and there is no movement under the star. All right? So that's what that information found out. And the reason why it was called Airy's failure is because he failed to prove that the earth was moving. So that's why it's called Airy's failure. So now we got another one. And this is probably the best one that proves that we are not moving. So this is going to be a real good one here. So in 1881, a man named another French scientist named Michelson Morley, he did a test using an interferometer, and pretty much he made light beams in his lab. So the goal was he was thinking that if he shoots a light beam if he shoots a light beam with the supposed rotation of the Earth east to west, if he shoots the rotation of the light beam one light beam to the rotation of the Earth east to west, and he shot another light beam north to south, that he was expecting that the light beam going north to south would would take longer to would take longer to complete its cycle because it's going against the rotation of the earth. Like for example, if you're in a river, if you're in a river and you're riding with the current, you're going to be going with the current. So the light would be an instance would be the light going east to west would be you, going with the going with the current of the water, right? And then the light going north to south would be you going against the current. So because there is this, what's the word? Because there is this resistance, there should have been a difference in speed of the light because you're going against the current. You're going against the current. So what Michelson Morley was expecting, that he was expecting that that the light beam would come back slower, right? So pretty much what was going on is here he shot one light beam east to west, going with the supposed rotation of the earth, and he shot another light beam going north to south, opposite of the earth rotation. The light going in the opposite direction should take longer because of resistance, right? So what he had ended up and what he was trying to find, he was trying to find fringe shifts, which means fringe shifts means speed differences. That's what fringe shifts mean, speed differences, because the Earth is supposed to move at 30 kilometers a second around the sun to complete its 365-day rotation around the Earth. So he ended up once he did that, he ended up finding out that there was no difference in the speed of light. Both lights hit the same. Both lights came back exactly the same, showing that the Earth was not moving. And this is very amazing. So let me bring up his paper that he did here. All right, so hold on. All right, here's a picture of the interferometer right here that Michelson Morley used. And right here in the first paragraph, we're going to skip the first line. It says, Professor Michelson used a set of mirrors to split a beam of light into two, then send the perpendicular beams of light on equally distant round trips. One light beam traveled against and then with the direction of the Earth's orbital motion, analogous to up and down trip on the conveyor belt. So here they're comparing it to a conveyor belt. It says while the other light beam traveled crosswise to the Earth motion, like how we talked about how I mentioned how he sent one light beam with the rotation of the Earth and another light beam against the rotation of the Earth in the opposite direction. And he sent and with the direction of the Earth orbital motion, analogous to up and down trip on the conveyor belt, while the other light beam traveled crosswise to the Earth motion, analogous to round trip across the conveyor belt. The Michelson interferometer would determine the difference in the return time of the two light beams. It says like the walker going crosswise to the conveyor belt, it was presumed that the light beam traveling crosswise to the Earth motion would win the race over the light beam that travels counter and with the Earth motion. Much to Michelson's surprise and no doubt chagrin, the round trips for the two lights took the same amount of time. All right. So the reason why he was so surprised is because he split this light beam, and he ended up doing this twice. He did it one time in 1881, and then he did it again in 1886. And when he did it again in 1886, he did it over 6 days, and he ran the trials and tested it and ran the same test 36 times. And the reason why it's so shocking because Michelson Morley he built a very sophisticated device. It could have easily detected a tenth of a difference in motion and speed. So it was a very, very precise machine. Just because it was 1887 does not mean the machine was precise. And don't forget, we still got more evidence proving that our Earth is not moving, and we have more evidence showing that, and we'll be getting into how the stars are aligned to us. And we're going to be seeing the evidence for that. So we still have a whole lot of good stuff coming that will take us up into modern day. So let's continue on. It says careful repetitions of the careful repetitions of the experiment only verified the original result. What were the implications of perhaps the most mind-boggling experiment in the history of physics? Is this Earth is oh the sorry. It says what were the implications of perhaps the most mind-boggling experiment in the history of physics? Is the Earth actually at rest, as was claimed by the religious zealots who persecuted poor Galileo? Question mark. Or perhaps the ancient Greek philosopher Parmenides was right after all in asserting the motion and change are not real but only an illusion. And look what they came up with too. So notice how well let me read it first. It says no less different than accepting the tenets of para of Parmenides philosophy. Modern day physics tell us the result of Michelson-Morley experiments are due to the fact that the space itself contracts just enough to cancel out the expected increase of travel of time. So pretty much what they're saying is, and a man by the name of Lorentz came up with this theory. So pretty much what he was saying, Michelson Morley showed Lorentz his results in 1881, and Lorentz had told him, he was like, maybe you just did some wrong math. So they did it again in 1887, and this time his instrument was even more precise and more sensitive. And he ended up finding that there was no real movement, and that the Earth was indeed not moving around the sun. So what Lorentz came up with was he was saying because the Earth is moving, because the Earth is moving through the ether, the light, because the Earth is moving through the ether and the ether contracts everything. So what he's pretty much saying is that the ether, and because the Earth is rotating through the ether contracted his light beam to such a degree that it showed that there was no motion. Now, isn't that funny? That how they came up with that. And so look at this. So now we have three scientists, three highly respectable scientists that have all shown us that the earth is not moving. And they keep ignoring the data. They will never go back and say, well, maybe the earth is really geocentric. They keep coming up with new ideas. And and Lorentz's theory ended up becoming the law of it was called length contractions, and the math that they put with it is the Lorentz transformation theory. The Lorentz transformation equation. So instead of just saying maybe the earth really is not moving, they keep coming up with more and more theories that they can't prove to try to keep us in the dark and keep us away from the fact that the earth really is geocentric, okay? Because you have to understand, science was invented so that we could lose our concept of God and free ourselves from this concept of God and only have to rely on the natural, that's around us, the natural world that is us, Mother Nature nonsense. And that we would just be able to live off of science and trust what science has to offer. But as you see, as we're going through the decades and as they get more sophisticated technology, science is only proving the fact that Yah's truth stands hold and steadfast. And when we read those scriptures in First Chronicles chapter 16 verse 30, when he says the earth is established and is immovable, those scriptures are holding true. Those scriptures are holding true. So what he ended up coming up with was the Lorentz contraction hypothesis, right? And so isn't that funny that they came up with a theory that would say that the earth that the ether is squishing, meaning the apparatus of his of Lorentz's interferometer to just enough that we can't detect the motion. Now, if you can't see the bias in that, I don't know what to tell you. And of course, we're going to have more empirical evidence proving that science is very much trying to steer itself away and trying to steer the people away from a centralized Earth. And as this video progresses, it's only going to get better. But we're going to listen to this clip here of a doctor named doctor of a scientist doctor named Robert Sungenis, and he goes into great detail about the Michelson-Morley experiment, and then goes into detail and clarifies it even more about the Lorentz experiment. So apparently, before we switch over to the clip, apparently Lorentz's machine Michelson-Morley's um, interferometer shrunk. That's what they're saying. That when you're moving with the rotation of the Earth through the ether, that things shrink. That's what they're saying. Such nonsense, right? And that his interferometer shrunk to just enough that he couldn't detect the motion of the Earth, right? So here we go. And now this video is going to be very important because it's also going to tie into how Einstein ended up coming up with the special theory of relativity. So we're going to see how they manipulated math and how they manipulated Michelson's results so they can have their heliocentric world, okay? So this is going to be very important here, all right? So here we go. And this is Dr. Robert Sungenis again.
So Michelson came up with this thing called an interferometer. And what an interferometer does is it takes two light beams and it sends them on a path. And then on the path back to the receiver, the light beams will either coincide in their wavelength or be disrupted in their wavelength. That is, the crest of one will meet the crest of the other, or the crest of one will meet the trail of the other. And if the crest meets the trail of the other, that means they're out of phase, they're out of sync. And these will cause fringe, what they call fringe shifts, fringe, F-R-I-N-G-E, shifts in a receiver that receives both these light waves coming back. And depending on the displacement of these fringe shifts, you can tell how much the waves have been displaced from one another. That is, you can tell whether wave A came back faster than wave B. All right? Now, they shouldn't be coming back faster. A and B should both be coming back fast, that's at the same speed, because light travels the same. You know, whatever way you shoot a light beam, it travels the same speed in whatever direction you point it. At least so they thought. Okay. The idea behind the interferometer was this: if we shoot a light beam, let's call it light beam A, from east to west, okay, east to west, that's the direction that the Earth is supposedly revolving around the sun. Okay, it's moving counterclockwise around the sun, and that's from west to east. Okay, so if we shoot a light beam from east to west in the opposite direction that the Earth is supposedly revolving around the sun, then that light beam should go slower than a light beam that is shot from, let's say, the equator up to the North Pole. All right. The reason for that is if there's a resistance. Let's just say the Earth was revolving around the sun and yet space was filled with air. Well, what would we expect? Well, we would expect that if we shot a light beam through that air, it's going to go slower than if we shot the light beam from the equator to the North Pole, because the light from the equator to the North Pole is not having the same resistance as the light shot from east to west. Okay, does that make sense?
It does, because one, it has no, it's not fighting against anything. It's just going in a straight line. The other is having to contend with going around the sun in the opposite direction. Is that what you're trying to say?
That's right.
Okay.
Yeah. And it's just like if you were in a pool of water, and there was the water. You know, what do they call those pools where the water automatically is creating a wave for you? You can go surf on them and all kinds
A
of.
wave making machine.
Yeah,
Mhm.
you know, so if the water is moving towards you, now if you're in the pool, well, there's a certain resistance now. That water is going by you, so there's a certain resistance. And if you shot a light beam in that water that was moving towards you, it would go slower than if that water was going the opposite direction, okay, because there's a resistance there. As a matter of fact, that's what all these other experiments in the 1800s found. Martinez Hooke and a few others found that light was slower in water that was going the opposite direction. So if space is filled with ether, which is a substance, well, that means that a light beam shot from east to west in the opposite the presumed revolution of the Earth, well, that light beam would go a little slower than one shot from the equator to the North Pole. So this is exactly what Michelson's experiment did. He did the first one in 1881, and he shot. What he had is he had a table, and the light beams would go back and forth, and then he shot perpendicular light beams across those, and so you had basically light beams going at a 90-degree angle. And he found that when he rotated the table to try to make the light beams coincide with the revolution of the Earth, he found that there's no difference in the light beams traveling east to west as opposed to those going from north to south or south to north. And this was disconcerting because the whole theory was that the ether would form some kind of resistance against the east-west light beam, enough where they could show that the Earth was moving at 30 kilometers per second around the sun. What they got was probably about 1/10 of 30 kilometers per second, let's say about 3 kilometers per second, okay? And so he hired, or he consulted, Michelson consulted with Heinrich Lorentz, who was another famous physicist at that time, and he said, what's going wrong here? And so Lorentz said, well, maybe one of you have a mathematical miscalculation in one of your equations here, and that's why the figure came out to be, 1/10 of what we expected. And so Michelson said, okay, all right, maybe you're right. So he prepared to do the experiment again in 1887, and he got funding from the National Academy of Sciences in the United States, and also from Alexander Graham Bell.
And this was the Michelson-Morley experiment?
Yeah, this is the second one now. This is he took on a partner now, Edward Morley, and did the second interferometer experiment in 1887, 6 years after the first one. And basically it was to find out whether the first experiment was valid. Is this result that was totally unexpected in 1881 going to stand up? Okay, so what you do the experiment again. So they did the experiment again, and now they made it even more sophisticated. It was going to be able to measure these light beams a lot more accurately than the 1881 version. And so they did the experiment. They did it over 6 days. They had 36 trials, and it came out to be almost exactly the same result as occurred in 1881. And that is they expected fringe shifts that were on the order of 30 kilometers per second of the Earth going around the sun, and what they got was, between 3 and 8 kilometers per second. All right? So, again, they were so disconcerted. what do you do with this? We've all believed that the Earth is revolving around the sun, and yet these experiments are showing that it's not revolving around the sun. Now, mind you, they can't have a result that's like 5 kilometers per second or 15 or 20. They have to have 30 because the Earth has to complete its orbit around the sun at 30 kilometers per second to finish it in 365 days.
Exactly.
You can't have it going any slower than that. All right.
Right.
So this was quite a dilemma. So they were scratching their heads for many, many years. Lorentz wrote to many people. He wrote to Oliver Lodge. He wrote to Lord Kelvin, Lord Rayleigh. These were all famous physicists in England at the time. And he said, what are we going to do about this experiment? And so he was, working at it, and finally came up with this theory that the reason the interferometer did not measure any displacement of the wavelengths was because since the Earth was moving, the ether was compressing both the Earth and the arm of Michelson's apparatus. Okay?
Mm-hmm.
So in other words, we expected the length of the wave to be x, but it's x minus y because as things move through the ether, they're compressed. And so now the x is not minus y, it's x minus 0. And so you have x as your remainder, and therefore that explains why Michael's interferometer could not detect that the Earth was moving. And that's because Michelson's interferometer was distorted. It was distorted as it moved. And they call this length contraction. In other words, if whatever direction you're moving, in the direction that you're moving, your body or the object is shortened in the lengthwise direction. The width and the depth are okay. It's just the length is going to be distorted because it's moving. That's the best thing he could come up with to explain Michelson's experiment. And he had no scientific basis for this whatsoever. He did try to go into electron theory and say that the electrons would be compressed, and therefore that would compress the length of Michelson's apparatus, and blah, blah, blah. But it was all theory. And he even called it a theory. As a matter of fact, I think one of his papers in 1886 was an attempt at a theory to explain Michelson's experiment.
Wow.
Yeah, so...
So it's sketchy at best.
Oh, yeah. I mean, this science kind of works like this somehow. They come up with a theory, and then a theory to explain the empirical evidence, and then they try to see if they can prove the theory, you see. And so science is by and large, it deals precisely along those paths where you see the evidence, it's disconcerting, so you make a theory of why it's that way, but it's just a theory. There's no proof to it. And it just so happened that there was another scientist named George Fitzgerald who had come up with the same idea that Lorentz had come up with right around the same time, and so they were exchanging notes. And Fitzgerald had written a letter to Lorentz in 1894, and he said, "Oh, I'm so glad you came up with this theory because I had come up with this theory, and everybody's laughing at me over here in Dublin." He was a physicist in Ireland at the time, and I have the actual letter that he wrote to Lorentz, complaining about how he was being laughed at for promoting this contraction theory of electrons to explain Michelson's experiment. But that's the only thing they came up with. Either that, or they would have to admit that the Earth wasn't moving, you see. They had two choices. You either say that the apparatus is contracting, or the Earth isn't moving. Now, which one do you think they're more inclined to accept?
The incredible shrinking machine, as quoted from your book.
Incredible shrinking machine, yes, that's what I call it.
Mm-hmm.
So anyway, that was the start of, it's ironic because science, modern science, and let's say it started after the time of Newton, modern science believed that the more information they would find in the natural sciences, the more they would explain away the Bible, theology, and we could just depend on science, you see. But what they were finding was just the opposite. All the experiments that they were doing were actually bringing them closer to the Bible and the Bible's view of cosmology, that is, that the earth is in the center and isn't moving, than all the centuries prior, when they did no science experiments, you see. So science basically got undercut by its own, or what they say, hoisted by its own petard.
Yeah.
That's what was happening.
Mm-hmm.
So, this is where they were stuck. Now, Einstein came along in 1905 with his famous paper, the electrodynamics of moving bodies. Now, there's the title, Moving Bodies, okay? The moving body in question here is the Earth, all right? So basically, Einstein's trying to explain by this famous paper how the electrodynamics that are going on can explain why this moving body that we believe is moving wasn't detected as moving by Michelson's experiment, okay? Now, he was very familiar with Lorentz's work. He was also familiar with the relativity theories promoted by Ernst Mach and Henri Poincaré, another French scientist. And so Einstein basically put all these things in a jar, shook them up, and came up with this special theory of relativity to explain Michelson's experiment. And basically what he did was he advanced beyond Lorentz's explanation of ether, and he said, well, look, you know what? We can make this very simple. If we just do away with the ether altogether, we can have an easier time explaining Michelson's experiment. And he knew that he had to do away with the ether because if the ether is out there, we should definitely be able to measure movement against that ether. See, it's not really hard because Michelson's experiment was so precise, it could have detected a difference in speed down to 1/100th of what he actually found. It was so powerful, a piece of machinery that he had built. And so Einstein knew instinctively that the only way that you can get out from under this cloud that was created by Michelson's experiment was just to say that ether doesn't exist. But that wasn't all. He still had to explain in a different way why Michelson's apparatus did not detect movement. You see, because that's basically what special relativity says. It says we can't detect movement. We don't know whether we're standing still or moving at uniform speed because we're not going to feel any inertial forces at those two speeds, either still or moving uniformly. So, and that's what special relativity deals with. So he still had to explain Michelson's experiment, and he didn't want to use ether because that would trap him the same way Lorentz was trapped. And so he said, okay, let's do away with ether, and let's just say that as an object moves, it's moving relative to other things, and so the length contracts of the object and the time dilates for the time that it's traveling, just as a principle of nature. Okay?
Yeah.
There you go.
And go ahead.
No, you go ahead.
Yeah, I was going to say, I was listening to a documentary, a very short one by Malcolm Bowden. Are you familiar with this fella?
Yes, he's another old fellow. He's been around for a long time.
Yeah, and he talked about this, and he said that the paradox of the clocks proves that Einstein was wrong. Would you agree with that?
Yes, definitely. And this was an objection brought up by Herbert Dingle in the 1940s and 50s. Herbert Dingle was a very famous physicist, and he's got accolades, after his name that are very impressive, very well known. He was a original supporter of Einstein's relativity theory, and then he came up with the clock paradox.
Could you explain the clock paradox to the audience that might not be familiar?
Yeah. What it's saying is you can use the twin paradox. That's probably what they're most familiar with.
Sure.
The twin paradox is, let's say you have two twins on Earth, and then one gets in a spaceship. We call him Twin B, and he goes away very fast on this spaceship, and then he comes back on this spaceship to Earth. Will he have the same age as Twin A? And special relativity says no. He will be younger. Twin B will be younger than Twin A, because when Twin B got in the spaceship and he traveled at a certain speed, and that speed will dilate time. Now, I think this is a misnomer. They should not be using the word dilate, because dilate actually means to enlarge. What they actually mean is contract. The time will contract for Twin B, and it will be a different time calibration than it would be for Twin A, who's still on Earth. Okay, so Twin A comes back. I'm sorry, Twin B comes back to Twin A, and he's younger. Well, Dingell's objection was, well, wait a minute. Didn't you say that everything was relative in special relativity theory? So why are you saying that if Twin B goes away, that Twin A can't age at the same rate as B, because the distance between Twin A and Twin B is all relative? Okay? The experiment is assuming that Twin A is standing still and Twin B is moving away from him, but you can't say that in relativity. Relativity says we can't tell the difference whether Twin B is moving away from Twin A or Twin A is moving away from Twin B.
Brilliant.
So how can you say that the time is changing for Twin B and not for Twin A?
That's right. You use relativity against itself.
Yeah, it eats itself up.
Yeah, it does.
And so that was Dingell's objection. Nobody ever answered him. But, Einstein was so popular at that time, nobody was listening to Dingell, and nobody wanted to listen. They had their answer from Einstein about how the world was running, and Einstein saved them from going back to the Middle Ages, where they believed the Earth was not moving. It was in the center of the universe, and that's all there was to it. So there's not much more somebody could say against Einstein, because he was basically the new Copernicus, so to speak. And he did save mankind from having to go back to the Middle Ages, because Michelson's experiment was empirical evidence that the Earth wasn't moving. And as a scientist, as I said before, you just can't walk away from this stuff and say, oh, well, that was just a mistake. No, it wasn't a mistake. I mean, Michelson did it twice and found almost the same result each time. Then he did it again in 1897. What he did was he took it out of the basement of Case Western University and put it up ground, because there were complaints that, well, maybe the ether wasn't moving right in the basement or something, So he moved it up above ground and got the same result. Okay, that was in 1897, 10 years later. Then he did it again with a guy named Miller in 1904. And then he did it again. Dayton Miller went on his own track and did it. He did 100,000 trials as compared to 36 done by Michelson Morley.
Okay, can you just repeat that number once again? 100,000 experiments?
100,000 trials, yeah.
And
he got the same.
You got the same results with each.
In fact, he got a little higher ether drift than Michelson Morley. He got an average between 5 and 8 kilometers per second. Theirs was around 4 to 5 kilometers per second. And he wasn't the only one. There were dozens of these experiments done over the course of the next, 3 decades, up until 1932 with a guy named Joos, Joos. They all found the same thing. They all found that they could not use interferometers to detect the Earth moving, but they would always get this residual effect. They would always get something, okay? 1, 2, 3, 4, 5 kilometers per second, so this was bothering them too. If the Earth isn't moving, well, then why are we having this little residual here? This little reaction. And I'll explain that later. But the fact is they could not show the Earth moving through space at 30 kilometers per second. And, so Einstein was basically a savior for them. He cooked up this special relativity theory to answer Michelson. And basically what he said was the reason Michelson's apparatus couldn't detect the Earth moving was because the arm of his apparatus shrunk just enough so that we could not see the Earth moving. Just enough. Okay? And time... Now this is the dilemma that they're in. If you're going to say that the object is shrinking, well, how much time is it going to take for that object to pass from point A to point B? That's interesting. If it's shortened, that means it's not going to reach the finish line at the same time, is it?
That's right.
Okay, so that means then we have to change the time as well. You got a little higher ether drift than Michelson-Morley. You got an average between 5 and 8 kilometers per second. Theirs was around 4 to 5 kilometers per second. And he wasn't the only one. There were dozens of these experiments done over the course of the next, 3 decades, up until 1932 with a guy named Joos, Joos. They all found the same thing. They all found that they could not use interferometers to detect the Earth moving, but they would always get this residual effect. They would always get something, okay? 1, 2, 3, 4, 5 kilometers per second, so this was bothering them too. If the Earth isn't moving, well then why are we having this little residual here, this little reaction? And I'll explain that later. But the fact is they could not show the Earth moving through space at 30 kilometers per second. And, so Einstein was basically a savior for them. He cooked up this special relativity theory to answer Michelson. And basically what he said was the reason Michelson's apparatus couldn't detect the Earth moving was because the arm of his apparatus shrunk just enough so that we could not see the Earth moving. Just enough. Okay? And time... Now this is the dilemma that they're in. If you're going to say that the object is shrinking, well, how much time is it going to take for that object to pass from point A to point B? That's interesting. If it's shortened, that means it's not going to reach the finish line at the same time, is it?
That's right.
Okay, so that means then we have to change the time as well, because that object has to pass from point A to point B in the same time as if it wasn't moving. And if we can't explain that, then we need to create another fudge factor, and that's called time dilation. Okay? So we change the time that this object moves so we can account for the fact that all of its mass goes past point B in the required time. Well, what does that do? Well, that means if you have an object that's compressing, let's say you have a putty, and you compress the putty down from a big ball to a little ball. What have you done? Well, you changed the density of that putty, right? A putty ball. All right. So if you contract an object, you're changing the density of that object, basically, because its dimensions are now different, but it has the same mass.
Mm-hmm.
So that its mass has to increase. Okay? Well, that's exactly what special relativity predicts also. The time is shrunk, the length is shrunk, but the mass increases. Okay? And all they do is they invert the equation from 1 over 1 minus v squared over c squared and invert it so they now can divide and get more mass for the object. So, it's a lot of trickery with math that they use on these things. And the ironic thing about this is that Lorentz, the guy that believed in ether and that Michelson's apparatus was shrinking because it was rubbing up against the ether as the Earth went around the sun, well, he came up with a formula called the Lorentz transform. Okay, and the Lorentz transform is basically an equation that will always make the ratio less than 1. And that is, if the ratio is less than 1, that means the object is smaller than it was when it was standing still. 1 would be when the object is standing still. and 1 minus would be when the object is moving. And Lorentz put that into an equation called the Lorentz transform, and that equation is probably the most famous equation in physics today. Every physics experiment that deals with objects in motion will incorporate the Lorentz transform in their calculation of how that object is moving. The whole theory of relativity from Einstein, whether it's special or general relativity that was invented later, all are based on this equation that Lorentz formulated in order to answer Michelson's experiment. And you can go on the internet and find it. Look up Lorentz transform, and you'll see an equation that says something like this. L prime equals L times the square root of 1 minus b squared over c squared. Okay? And the reason he put it in those parameters was because that would make the length always less than the original length if that thing was standing still. And that's what they needed. And Einstein commandeered this formula from Lorentz, except he didn't use ether. Yeah, that's the difference between the Lorentz and Einstein is Lorentz at least had a physical basis for why he said these things were shrinking and time was shrinking because they were rubbing up against ether. Einstein got rid of the ether and just said, well, when things move, it's just a principle of nature. They shrink and time contracts. And nobody asks any more questions after that. So
Just accept it.
just accepted it because it was Albert Einstein. And
So the mental gymnastics that Einstein had to perform to get rid of this experiment are extraordinary.
Extraordinary, yeah. Yeah, it's like a haunted house of mirrors. Nothing is as it appears to be. Lengths are shortened, time is distorted, and mass increases. You ever walk in front of one of those mirrors at an amusement park,
I have indeed.
and it's wavy, and you see your body all distorted?
Mm-hmm.
Well, that's pretty much what special relativity did to science. It was a total revamping of physical science. That's why it was so important, okay? And that's why it's a revolution in science.
I heard that some of the best scientists in the world that were first exposed to Einstein's relativity walked out after he was finished. Is that so?
Oh, yeah, there were a lot of people that didn't accept. I have a whole list of them. There's probably about 50 names of famous scientists who rejected special relativity. Albert Michelson was one of them. Never accepted it to the day of his death. And Dayton Miller never accepted it. He's the other guy I told you about.
Mm-hmm.
Even Max, is it Planck? Yeah, Planck, I forget which, Max Planck didn't like either special or general relativity, one or the other. But yeah, he had a lot of enemies.
Mm.
This was a theory that, it couldn't be proved, okay? Some will come along and say, yeah, well, we can prove that mass increases, in a cyclotron, They're not proving that mass increases in the cyclotron. So in fact, this was one of the arguments that Dingle had brought up, that we can't say that because that's not what's going on in the process. And even from an ether-based scientific foundation, you can say that the reason that electron appears to gain mass is because it's running through the ether, and there's an ether pressure there. So it's going to look like that the electron has more mass. So even the supposed proofs that they have that special relativity is true are not proofs at all. It's just the way they interpret things. But people need to know, and that's the education we want to give them now, is the birth of special relativity, Einstein's relativity, was not because it was some I don't know what you would call it, a theory that just grabbed everybody's intellects and just was so persuasive that we just couldn't avoid it. That was not the case at all. Special relativity was invented for one reason and one reason only, and that was to explain away Michelson-Morley's experiment that showed the Earth wasn't moving. That's why it was created, okay? So people need to know that. That's the basis of it. And the whole you can understand the whole thing too, because if you have it's called a special theory of relativity. Well, what does relativity mean? Relativity means there is no non-moving object. There is no Earth that is not moving. Otherwise, nothing would be relative.
So wow, look at that. Look how the cover-up of the true information has been completely manipulated. For 25 years, they could not disprove Michelson-Morley's test, and they still can't. Albert, like Dr. Sanjena said, Albert Einstein very had to do tons of mental gymnastics to prove away this Michelson-Morley test. Because if it was so easily explained away, they would have been jumping all over it. They would have easily done away with it. But you see how scientists have manipulated the math that we use, how scientists have come up with all these theories and all these different equations that makes the answers they want to see come out. Ain't that something? Now, I told you this video was going to be juicy, and it's just amazing. So now we have like 5 scientists now that have all seen the true information, and they just keep on covering it up. And of course, we ain't done yet. It's only going to get better. It's only going to get better and more undeniable as we go along on this journey, all right? So now let's look at our man, Edwin Hubble. Let's look at our man, Edwin Hubble, all right? All right, hold on. Give me a second. All right, cool. So now we here at the Edwin Hubble book here, which is called The Observational Approach to Cosmology. So basically, in this book here, he's taken a survey of all the galaxies and trying to see how far away they are, and he's trying to come up with more scientific proof using starlight and the distance of galaxies to see how far away they are from the Earth and that stuff. All right. So right here, he wrote this book in 1937. So this is a few decades after Albert Einstein came up with his special theory of relativity that we have uncovered, which is very biased. So of course, as we go through the decades, we're just going to see even more the hiding and the misuse of information here. So let's go to page 6, because this book has, and I'm going to leave a link, or at least try to leave a link of this book here in the video so you can actually see all the information and read it if you want to. But I'll just be reading what we need to see. So let's go to page 6 right here. So right here on page 6, he writes about the Copernican revolution. Alright, so it says, the universe of the Greeks was a small sphere. The center was the earth. The boundary, the thin shell of the fixed stars. Between lay the orbits of the sun, the moon, and the planets. The whole heavens, it was believed, rotated once a day around the motionless earth. And we know, and let me just stop right here, we already know that the science has already proven that we are not moving. Through the Dominic Orrego test, through the George Biddle Airy telescope test, through the infamous Michelson-Morley test that we saw how much work they had to do to cover it up. So we already know, and we can already see that Edwin Hubble is coming with the same philosophical bias of this Copernican principle. All right, so let's keep on reading, because we've already shot down the evidence, and we've already shot down the scientists, the foundations of their beliefs. So let's see what he has to say. It says, the daily rotation of the heavens carrying along all the contents, sun, moon, planets, and stars, was directly responsible both for the small scale of the universe and for the thin boundary shell of the stars. The larger the universe, the more tremendous would be the speed of rotation. Deliberate effects were made to keep the universe as a deliberate effects were made to keep the universe as small as possible. No, it wasn't. That's the word of Yah. The word of Yah lets us know that we are in this small universe that's not vast and expanding. All right, so let's continue on. The orbits of the planets were packed together as closely as their supposed motions would permit. The stars were confined to a thin boundary shell, pressed tightly around the orbit of the outermost planet. The the minimum radius eventually adopted was 20,000 times the radius of the Earth, 80 millions of miles. Even so, a star on celestial equator the celestial equator travels 6,000 miles per second in its daily rotation. The Greeks' concept of a small, closed universe was accepted almost without question until the Copernican revolution. Copernicus not only transferred the center of the planetary system from the Earth to the Sun, but also transferred the daily rotation of the heavens to the Earth. No longer did the huge universe whirl madly around the motionless Earth. Instead, the Earth itself, at a modest rate, was spinning in a motionless universe, which we already know is wrong, because multiple scientists have proven this wrong. And Albert Einstein had to do mental gymnastics to cover up the true information of Michelson-Morley. And you notice, are you seeing the bias? And you seeing how the empirical data is proven and showing that the Bible is real and that the earth really isn't moving. But as you know, a lot of these scientists are atheists, and a lot of these scientists hate the idea of a God ruling over them, and they want to do what they want to do. So that's what they came up with science to try to deviate from that. But like Dr. Senjanis has let us know, that the more technology we have gotten, only the more that we've just proven the truth of Yah. And the last bit of this video, the information, is going to be very good. So you want to stick around. All right. So it says, thus Copernicus removed the necessity for a small scale universe and for a thin boundary shell of stars as well. He was primarily concerned with the planets and did not himself take the logical step of scattering the stars through infinite space. The step was reserved for an Englishman, Thomas Digges, who 43 years later, in 1576, assumed it is an obvious and welcome consequence of the new cosmology. And notice here, when look at the year. So 43 years later, so that means Copernicus came up with this idea in 1533. And in 1533, they trying to say that the Earth is this spinning ball that is moving around the sun. And which we all know, in 1533 there was absolutely no technology to even come close to proving this stuff to being true. They were coming from their own personal philosophical bias. There was no way to prove this, but because someone tried to find out a way to make it seem like we're insignificant and that there is no God ruling over us, a lot of scientists and philosophers ran with that because a lot of these people are atheists. They have no Yah in them. So make sure we take note that in 1533, Copernicus was coming up with this idea when there was absolutely no way on Earth to prove such a thing, when there was no planes, no super powerful telescopes, no nothing that could even get us remotely to proving this theory to be correct. It was just all off of philosophical bias and how they wanted to interpret the stars. Okay? it says so, and it says assumed. It says Thomas Digges, who 43 years later, in 1576, assumed it is an obvious and welcome consequence of the new cosmology. The restless imagination, it seemed, had been loath to postulate a universe boundary, but had been forced to that extremity by what appeared to be the hard facts of nature. Now there emerged a possible, alternative interpretation of those facts. A choice was presented between a small, bounded universe centered around the observer and a universe indefinitely large plus an unfamiliar principle of relative motion. And there's that line again, relative motion, that we know that Albert Einstein just came up to disprove the Michelson-Morley test. And you have to take note that it took him 25 years, almost 30 years, to find a way to deviate away from the Michelson-Morley test. 25 years, they changed the map, they changed the dynamics of space. They did all these things to try to disprove that the Earth wasn't moving. Instead of just saying, like, maybe the Earth is geocentric. Maybe there is this Yah, this Elohim in the heavens watching over all of us. And I have some cool Bible verses that will talk about how Yah feels about our scientists and all that, and it's going to be very eye-opening. And if you're still with me in this video, I'm sure you're seeing all this information is very eye-opening. And that's why they say if you want to hide something from a person, just put it in a book. Because not a lot of people read or do the evidence. But we're going to do this evidence and we're going to read this information. Because I'm tired of living lies. I'm tired of watching all the good people live these lies and destroy yourselves. So we got to bring this truth to light. It says definite observational evidence to guide the choice was slow to materialize. Nevertheless, the larger universe, with all its significance, was adopted quite early, meaning no way to prove it, on the grounds of simplicity and uniformity. It was recognized that the system of the planets centered around the sun was isolated and lonely in space, that the sun itself was but one of a myriad of stars scattered at vast intervals through the universe. Which it is not, because the Bible clearly says in Genesis. Let me read that actually. Let me read that. I won't just say it off the top of my head. I'll read it. In Genesis chapter 1. So we take a quick pause from this book here. It said, let's see, where is it? Oh, it says right here. It said, God created the sun and the moon and the stars also. He put the sun he made the sun the greater light to rule over the day, and the moon to rule over the night, and the stars to rule over the night as well with the moon. So Yah makes a very distinct difference between the sun, moon, and the stars. The sun is not another star, okay? The sun is the sun, the moon is the moon, and the stars are the stars. Three different entities, okay? Three different luminaries. That's what they're called in the Bible. The stars are called the luminaries. All right, so back to the book. So now let's go to page 20 because understanding redshifts will plays a big part in this. So we have to understand redshifts. All right, scroll down a little bit. All right, we're going to start right here at spectrum analysis. It says, let us begin with a simple description of spectra. Light is radiated in waves of many different lengths. The eye rather crudely distinguishes the different wavelengths as colors. Long waves are red, and short waves are blue or violet. When we look at luminous bodies, the eye receives a beam of composite light, many different colors, mixed in different proportions. However, If the beam of light passes through a glass prism or other suitable device, the individual rays are bent in different degrees depending on the wavelength, and the colors are spread out in an ordered sequence called a spectrum. The rainbow is a familiar example. The sequence never varies. From the long waves of light, the wavelengths steadily diminish to short waves of violet. The spectrum may be long or short, depending on the apparatus, but the relative positions in the sequence remain unchanged. Position in the spectrum indicates the wavelength. So in these brief paragraphs, Edwin Hubble is describing how wavelengths work through the light spectrum and how we see them. Like when an object is further away, it appears to be more red, and when an object is closer to us, it appears to be blue. So it says of the particular light in question, relative brightness at the position indicates the relative abundance of the particular wavelengths in the composite radiation. Therefore, a spectrum furnishes valuable information concerning a distant light source because it indicates the particular colors that are radiant and their relative abundance. It says, for instance, an incandescent solid, such as an electric filament, radiates all possible colors. The spectrum is continuous from red to violet and beyond in either direction. The relative abundance of the various colors measure the temperature of the light source. Again, an incandescent gas, such as a neon sign, radiates only certain particular colors. The spectrum, known as the emission spectrum, is a pattern of isolated colors separated by dark gaps. The pattern is a characteristic of particular gas involved. Hence, an emission spectrum serves to identify the chemical composition of a distant, inaccessible light source. There is still a third type of spectrum, and it is of special interest for our immediate purpose. When an incandescent solid or equivalent source giving a continuous spectrum is surrounded by a cooler gas, for instance, a star, with its surrounding atmosphere, then the gas absorbs from the continuous spectrum of the background just those colors which it would emit if it were itself incandescent or isolated. The result is called an absorption spectrum. It presents a fairly continuous background, interpreted by dark gaps, or lines within which represent the colors absorbed by the superimposed gas. The distribution of the intensities in the continuous spectrum indicates the temperature of the star, and the pattern of dark absorption lines identifies the gases in the stellar atmosphere. Absorption light in the spectrum of the sun indicate the presence of many of the most of the elements known in the laboratory. Lines due to metal vapor or predominant, the most conspicuous being a closed pair of calcium lines in violet regions, known as the H and K lines. Other conspicuous lines are due to iron and hydrogen. Now, the spectra of nebula are very similar to the spectrum of the sun. Stellar systems, it appears, as dominated by yellow dwarf stars like the sun. The nebula in general are so faint that their light can be spread over very short spectra. Nevertheless, even the small scales, the H and K lines of calcium, are strong and unmistakable, and more conspicuous lines of iron, hydrogen can also be identified. So pretty much he's looking at these stars and he's saying, these stars are kind of the same color as the sun. So I wonder if those are other stars or those are other suns out there, just like our sun. So pretty, what he was doing is he was seeing these galaxies and these stars, and he was saying like, I see these galaxies, so we must be in one of these galaxies because we can't see ourselves in our supposed galaxy. So he was assuming that we were in one of those other spiral galaxies because he sees them out there, and he said we must be in one of those, and they look similar. The light looks similar to the sun's light, but we already know from the word of Yah that the sun is the sun, the moon is the moon, and the stars are different entities. All right, so that's what he was assuming through this stuff. And now we break down even more what redshifts mean. It says, although the spectra of the sun of the nebula exhibit the same pattern of absorption lines, there is one remarkable difference. The lines in the nebular spectra is general, are not in their normal positions. They are displaced towards the red end of the spectrum, to the positions representing wavelengths somewhat longer than normal. The entire pattern of absorption lines, all details in a spectrum, appear to have been shifted towards the red. These displacements are commonly known as redshifts. They are characteristic features in the spectra of all nebula except a few that are in the immediate neighborhood of our own stellar system. So right there, he's assuming that we are in one of these spiral galaxies, which we know that we are not. We are not in one of those spiral galaxies. The stars are the stars, the sun is the sun, the moon is the moon, and we are in it. All right, and it says, and it continue on. It says each line is given spectrum is each line in a given spectrum is shifted by a certain constant fraction of its normal wavelength. The linear shifts vary with the wavelength, but fractional shifts remains consistent. Therefore, the redshift in particular nebula is specified by that equation, and in its which varies from the nebula. The study of many nebulae has shown that on average the redshifts increase with the apparent faintness of the nebula in which they are measured. Therefore, we conclude that on average redshifts increase with distance. Extensive investigations have demonstrated the relation is approximately linear. All right. It says when first observed, the redshifts were immediately attributed to radial motion away from the observer, to recession of the nebula. This interpretation still remains the only permissible explanation that is known. It is true that other ways are known by which redshifts might be produced, but in each case they would be accompanied by other phenomena which would be conspicuous and actually are not found. We may state with some confidence that redshifts are the familiar velocity shifts, or else represent some unrecognized principle of nature. We cannot assume that our knowledge of physical principles is yet complete. Nevertheless, we should not replace a known, familiar principle by an ad hoc explanation unless we are forced to that step by actual observation. So right here he's saying, so he's letting us know that when you look at the nebulas, he's saying it very much appears that when I look at the nebula, that the nebulas have these redshifts that make us think that they're moving away from the observer, right? And he's saying that it is assumed that redshifts are the familiar velocity shifts. And he says, we will not, he's pretty much saying we will not accept another principle unless we are forced to that step by an actual observation. All right. Let's continue on. It says most of the theoretical investigators adopt this point of view. And he's saying that's why he's saying, because everybody's believing this thing. Albert Einstein already came with his laws of special relativity and general relativity theories. So we don't have no other reason. He's saying everybody already believed this crap. He says most of the theoretical investigators adopt this point of view and accept without question the interpretation of redshifts as velocity shifts. And I want us to really remember this about how scientists are interpreting redshifts as velocity shifts, because later in his book we're going to see how that comes to play a very high bias. All right. It says they are fully justified in their position until evidence to the contrary is forthcoming. But these lectures will present a remarkable situation. The familiar interpretation of redshifts seem to imply a strange and dubious universe, very young and very small. And on the other hand, the plausible and in a sense familiar conception of a universe extending indefinitely in space and time, a universe vastly greater than the observable region, seems to imply the redshifts are not primarily velocity shifts. So right here, Edwin Hubble is saying, when I'm looking at this information already, he's saying this seems to be strange and dubious. He's saying these galaxies seem to be showing us that we are very young and very small. And it says, on the other hand, the plausible and in a sense familiar conception of the universe expanding indefinitely in space and time, a universe vastly greater than the observable region, seems to imply that redshifts are not primarily velocity shifts. So notice already he's looking at this information and he's writing it down as he's seeing it. And he's writing his book. He's already letting us know that things are not really looking the way I expect it to be. Okay, so notice that he's already seeing signs of a very young and very small universe, which we know is what the Bible talks about. Not being the so the Bible lets us know clearly that it did not take millions of billions of years for things to happen. We know from the Bible that our world is very young and very small because we are the focal point. We are the center of it all. Yah loves his creation. All right. So right here we're already seeing some evidence, and he's already seeing evidence that would show that things are not the way the scientists want it to be. So let's continue on. And we're going to see, especially when we get to about page 39 and definitely 40, definitely 39 and 40, we're going to see how it all plays, But of course, we're not going to read 22 all the way down there. All right, so it says, in view of this possible conflict, whether of facts or theories or speculation, the observer is inclined to keep an open mind and to adopt parallel working hypotheses for the interpretations of his explorations. He may assume first the redshifts are velocity shifts, or secondly, the redshifts result from some unknown principle that does not involve actual motion. And always, of course, he will search for some empirical critical test for distinguishing between the two assumptions, between motion and no motion. So he's seeing evidence that could show both signs, okay? So this is what this book is about. So now, let's go to page 29. So as you see, it's entitled Alternate Laws of Redshifts Not Interpreted as Velocity Shifts. Because remember, with Albert Einstein's laws of general relativity and special theory of relativity, both worlds are possible. A geocentric world and a heliocentric world are possible because special relativity and general relativity talks about how you can't tell if we're moving and how you can't tell if anything else is moving. Everything is relative and everything's always moving, but you can't tell. So it is possible that you can have a geocentric universe, which is the true universe we live in, which I'll always defend. The geocentric universe and the heliocentric universe. So both theories allow a heliocentric view of the world and a geocentric view of the world to be plausible. So that's why Edwin Hubble is having this conversation and writing these things down. So it says right here, it says red shifts not interpreted as velocity shifts. It says, let us start with the precise formulation of the laws of redshifts. The best data for the purpose are those found in great clusters of nebula, for nine or 10 of which reliable redshifts and distances have been derived from the brighter members. The distances range from about 7 million to 240 million light years, the latter being the greatest reliable distance that has been assigned to an individual object. If the particulars in the observer if the particularities in the behavior of redshifts can be detected at the present time, they will be found in this group of data. The observational data are quite simple. They consist merely of measured redshifts and measured luminosities, corrected for energy effects. The luminosities indicate the distances, which, of course, are expressed on two scales according to whether or not the recession factor are introduced, except for the choice of scales. The relative distance are reliable. It says, now let us adopt the first alternative and assume that red shifts are not velocity shifts, that the universe is not rapidly expanding. In this case, the red shifts are strictly proportional to the distance over the entire range of the data within a very small uncertainties of the measures. The law of redshifts is strictly linear as far out into space as the spectra has been recorded. The law is expressed as follows. So when he says within the very small uncertainties of the measures, the law of redshifts is strictly linear as far out into space as spectra have been recorded. He's saying that all the redshifts are aligned in a straight line and are uniform. He's saying they're all aligned along a straight line, pretty much. That's what that means when he says linear. All right, so let's continue on. The implications of this result are important. If redshifts are not velocity shifts, light loses energy strictly in proportion to the distance it travels through space. As light streams in from the remote nebula in all directions, each million years of the light path subtracts the same fraction of energy from the quanta. We may not know how the reduction is accomplished, but we do know that the action is everywhere uniform. Within the small uncertainties of the measures, the sample of the universe can be explored with spectrographs is thoroughly homogeneous. So so when he says homogeneous, he just means it's alike everywhere he's looking. So pretty much the Big Bang Theory says that we're expanding outward and everything is moving away from us faster and faster. So he's saying if the red shifts are not velocity shifts, that means the nebulas are actually losing light and not the nebulas are actually losing light and not expanding away from us in this vast and this vast speed, and they're strictly proportional because he's seeing this everywhere. When he's looking through his telescope, he's seeing that the nebulas are losing energy in all directions, and he's saying that when he evaluates the universe, that it can be explored with spectrographs. It's thoroughly homogeneous, meaning this action is alike in all directions. He's looking at it. All right. So let's continue on. So right here, he gives us his evidence here for it, and his chart, and he explains it down here. All right. And don't forget, I'm going to try to leave this book in the description of the video so you can look at this yourself. All right. So it says there are no systematic departures from uniformity whose trends can be pushed out into the universe at large. The homogeneity may extend indefinitely, or trends may exist which only become appreciable beyond the range of the spectrographs. On this question, our knowledge fails, and we are reduced to mere speculation. So he's already admitting that he don't know everything. If the explored region is a fair sample, it is relatively insignificant, and it furnishes only negative information concerning a universe that must be vastly greater. The conclusion seems plausible and in a sense familiar. So he's looking at this evidence, and he's saying, yo, if this is true, our expanding universe theory is shot out the door. And he said to himself, the conclusion seems plausible and in a sense familiar. It's familiar to what? To a central universe, okay, which we will see him admit to. So he's looking at this information, and he's already seeing that things are not what they expect to be. So now let's go to page 31. Actually, page 35. That's what I want. All right, now we have here what he calls the dilemma. He says, thus, the familiar interpretations of redshifts as velocity shifts leads to strange and dubious conclusions, while the unknown alternative interpretation leads to conclusions that seem plausible and even familiar. So he's already admitting, he's saying we're interpreting this thing as a velocity shift, but he says this shows strange and dubious conclusions, meaning it's not adding up. He says while the unknown alternative interpretation leads to conclusions that seem plausible and even familiar. Theories may be revised. New information may alter the complexion of things, but meanwhile we face a rather serious dilemma. It says some there are who stoutly maintain that the earth may well be older than the expansion of the universe. Others suggest that those crowded jostling yesterdays, the rhythm of the events were faster than the rhythm of the spacious universe today. Evolution that then proceeded apace and into a faint surviving into the faint surviving traces which we now misread the evidence of great antiquity. Our knowledge is too meager to estimate the value of such speculations, but they sound like special pleading, like forced solutions of the difficulty. The fundamental question is the interpretation of redshifts. So he's saying, how do we want to look at this thing? And how do we want to look at this thing? And notice, and before I continue on, and notice how it says so there are some it says some there are who stoutly maintain that the earth may be well older than the expansion of the universe. And the Bible lets us know that the stars and the sun did not come until after the earth was already laid down and after the earth was already there. So they're already seeing the science behind the truth of Yah. And I'll read that to you. It says, and Elohim said, let the earth bring forth grass, the plant that yields seeds, and the fruit trees that yield the fruits according to its kind, whose seeds in itself on the earth. And it came to be so. And the earth brought forth grass, the plant, the yield that yields seeds according to its kind, and the tree that yields fruit, whose seeds is in itself according to its kind. And Elohim saw that it was good. And there came to be evening, and there came to be morning, the third day. And this is the fourth day coming up. He says, and Elohim said, let lights come to be in the heavens to separate the day from the night. So you see, plants, the earth, water was already here before the star. Now he says, let there be lights that come into the heavens, talking about the stars. So we already know that everything was already here before that. So when he says that that there's information, and he's saying there's some that maintain that the earth may be well older than the expanse of the universe, that is true, because Yah lets us know that the earth was already founded and was already here before the stars and the sun got here. But don't worry, it gets better. It gets better. All right. So like I was saying, they're trying to say that he says the question is, how do we want to interpret these redshifts? Do we want to interpret it as that they're expanding far away from us, or do we want to interpret it as the nebula are losing lights, and that everything is expanding from us in a way that shows that the earth was here first and everything expanded from the earth? And we will see what his answer will be in the next coming pages that I'll be reading. So now let's continue on, and we're going to go to page 37, and it's going to get juicy. We get into the meat of the stuff. So now you're seeing that the evidence that Hubble is seeing through his telescopes is not showing that redshifts are velocity shifts. It is showing him a universe that might be a lot younger, and it's showing him that the Earth is also younger. I mean, the Earth is older than the stars around it. So we're going to read surveys of the nebula. It says, the present lecture describes similar results which are derived from the laws of nebular distribution as formulated with the alternative scale of distance. The preliminary reconnaissance had indicated that the large-scale distribution is at least roughly uniform. Guided by this information, accurate surveys were planned for the purpose of formulating precisely the law of distribution. 5 such surveys have now been reported, made with three large reflectors by 2 observers working independently. One survey was made by Dr. Mayall with the 36-inch reflector at the Lick Observatory. The others were made at Mount Wilson Observatory, 2 with the 66-inch reflectors and 2 with the 100-inch. The results are internally consistent, and the diversity of the investigations offer some assurance against the presence of the hidden systematic errors. The nightmare of the cautious observer, which might vitiate the conclusion. It says each survey, although it required many months or some years for completion. It is summarized by a single symbol, which represents the average number of nebula per unit area, brighter than a specified limit of apparent faintness. It is unnecessary to describe the simple but laborious methods by which the nebular counts were reduced to a standard homogeneous system. The limits the limits of apparent faintness determined with considerable accuracy. It is sufficient to say that in their final forms the surveys represent about 100,000 nebula, and that the distances correspond to the limits of the surveys range from about 150 to 400 million light years. The surveys, it will be noticed, extended far back into times as well as far into space. Analysis of the survey consists in the comparison of numbers of nebula with the volumes of space they occupy. If the large-scale distribution is uniform, the numbers will evidently be proportional to the volumes. If the proportionality does not emerge from the data, we must conclude that the observable region is not homogeneous. The discrepancies must be examined in order to find whether they represent random variations within the sample, or departures from the uniformity which vary systematically with distance. Systematic departures would be important because the trend could be pushed out beyond the limits of the telescope to furnish positive information concerning the universe at large. On the other hand, homogeneity, or random variations, would suggest that our sample is small, insignificant portion of the universe. Alright, cool. And now we go to page 39, where we start to see the results of what the Mount Wilson Observatory brought back and Dr. Mayall brought back. We're going to see what they found. And this is the meat of what we are trying to learn from Edwin Hubble's book here. It says we can now formulate the law of nebular distribution on assumption that the nebula are not rapidly receding. Look at that. The energy correction corresponds to the energy corrections corresponding to redshifts at the limits of the various surveys exactly compensate for the apparent thinning out of the world picture. Numbers of nebula are strictly proportional to the volumes of space they occupy. If the universe is not rapidly expanding, the observable region is thoroughly homogeneous out as far as accurate surveys have been extended. Meaning that if the universe is not rapidly exceeding what I appear to be seeing in my telescope, that all the stars are moving away from us, showing us that we are the center, is true, and that the nebula are losing light as the nebula are losing light is true, and that they're not rapidly exceeding away, and pretty much that the world is older than the universe and that stuff. So it says the important conclusion is derived by comparing simple counts of nebula which measured luminosities, corrected by energy factors which must be applied to such measures regardless of cosmological theory. The uniform distribution is plausible and welcome result. Homogeneity within our sample seems so plausible, in fact, that it has often been adopted as a preliminary assumption. The apparent distribution indicated by the crude observations is then described as true. Uniform distribution plus apparent departures from uniformity. The apparent departures can be expressed as corrections to the measured luminosities of the nebula at the limit of the variation survey, and these corrections in turn can be compared with the redshifts at the same limit. The results expressed in terms of magnitude increments. It says, which agrees very closely to the energy correction. Now, listen, this is the juicy part. I want you all to pay attention to this. Listen to this, all right? This is very, very, very telling and very important. The energy corrections, it will be recalled, are total effects of the redshifts on apparent luminosity, provided redshifts are not velocity shifts. The latter interpretation seems to follow directly from the preliminary assumption of uniformity. The assumption of uniformity has much to be said in its favor. If the distributions were not uniform, it would either increase with distance or decrease. But we would not expect to find a distribution in which the density increases with distance symmetrically in all directions. Now, pay attention to this next line. Pay attention. This is Edwin Hubble's own words. It says, such a condition would imply that we occupy a unique position in the universe, analogous in a sense to the ancient conception of a central earth. So bam, right here, he has proved that when he looked at the stars and he saw the redshifts departing from us in every direction we looked, it was showing him, because he was looking for red shifts and blue shifts, because he was expecting that some stars and some galaxies would be closer, further away, but he only saw red shifts in all directions everywhere he looked. Okay? And he says such a condition would imply that we occupy a unique position in the universe, analogous in a sense to the ancient conception of a central earth. And listen, look at his next words. Look at his next words. The hypothesis cannot be disproven. The hypothesis cannot be disproven. The hypothesis cannot be disproven. But what does he say? But it is unwelcomed and would be accepted only as a last resort in order to save the phenomena. Therefore, we disregard this possibility and consider the alternative, namely a distribution which thins out with distance. You should be flabbergasted. I was flabbergasted when I heard this. Well, when I read this information. He's seeing the truth. He's seeing that we are a central earth. He's seeing that he looks and he's seeing that all the redshifts around our universe are coming from us, meaning that everything had, when it expanded out from us, meaning that it came from us and expanded outward. That's why he's seeing symmetrical red shifts in every direction. And there's no shift, no blue shift, no red shift. And he says it, such a condition would imply that the earth, that we occupy a unique position in the universe. And he says, in a sense, to the ancient conception of a central earth. He even says the hypothesis cannot be disproven. He says there's no way to disprove this fact. It cannot be, this is his own words. The hypothesis cannot be disproven, but is unwelcomed. Listen to that, because remember I told you, remember I said, remember those words, how the scientists favor the rapidly expanding universe and that redshifts are velocity shifts and that they wouldn't let go of it unless they found some very hard evidence. And remember, he said we shouldn't just change our mind to ad hoc theories and stuff. And look at him. He's saying, but it is unwelcome and would be accepted only as a last resort to save the phenomena. Meaning, we're not going to admit to this unless we have to. Therefore, we disregard this possibility and consider alternatively, namely a distribution which thins out with distance. Can you believe that? He's seeing the truth. He's supposed to be a scientist leading us to truth. But we already know from the Michelson Morley, from the George Biddle Airy, from the Dominic Orrego, they're not going to admit to it. They already found the evidence proving that we are the center. And as we got more and more technology, it just sweeps their idea of an expanding universe and under the rug, and they have to keep coming up with all these different theories to prove their case. And look at those hard, true words. And then in the next paragraph, he starts talking about how they are going to mask this truth and make it appear to be in their way, so that they can keep their heliocentric world. And then after I read this, I'll show a clip of Dr. St. Jonas explaining this in depth even more. He says, and look at this. He says a thinning out would be readily explained in either two ways. The first is space absorption. If the nebula were seen through a tenuous haze, they would fade away faster than could be accounted for by the distance and redshifts alone. And the distribution, even if it were uniform, would appear to thin out. The second explanation is a super system of nebula, isolated in a large world, with our own nebula somewhere near the center. In this case, the real distribution would thin out after all the proper corrections had been applied. And look at this next. Look at the next paragraph. It's just astounding. This is just astounding that Edwin Hubble found the truth and he realized the truth. But of course, they been knew the truth. But he's just like, nah, we're not gonna accept that. We want our heliocentric world. Look at this. Look at this. It says both explanations seem plausible, but neither is permitted by the observations. Meaning they seem plausible, yeah, they could fly, but that's not what I'm seeing through my telescope. He said the apparent departures from uniformity in the world picture are fully compensated by the minimum possible corrections for the redshifts on any interpretation, meaning no matter how they want to interpret it, they can manipulate it to make it seem what they want. He says right there, he says the world picture are fully compensated by the minimum possibility corrections for redshifts on any interpretation, meaning both these can fly however he wants to do it, meaning he can manipulate it to look like how he wants to. It says no margin is left for a thinning out, meaning there is no way the universe is thinning out. It says the true distribution must either be uniform or increase outward. And he reiterates it again, leaving the observer in a unique position. It says, but the unwelcome supposition of a favored location, look at this, must be avoided at all cost. Look at those hard words. It said, but the unwelcome supposition of a favored location must be avoided at all cost. Therefore, we accept the uniform distribution and assume that space is sensibly transparent. Then the data from the survey are simply and fully accounted for by the energy corrections alone, without the additional postulate of an expanding universe. Are you seeing that? He's saying that he wrote it in his own book. He's saying a favored location must be avoided at all costs. Look at this bias. They're seeing the truth. They're seeing that we are the center, and they don't like it because science is supposed to get us away from the Bible. But yet Edwin Hubble is writing it down in his book. What a fool. He should have never wrote it down at all because old Calvin found it. And Yah led me right to this evidence. It says, and looking back in the second to last paragraph that we just read, it says the hypothesis cannot be disproven, but it is unwelcome and would be accepted only as a last result. Therefore, we disregard this possibility and consider alternative, namely a distribution which thins out with distance, the great expanding universe. And he says it right there. He's saying the true distribution. I can't even talk right, man. This information is getting me so mad. It says the true distribution must either be uniform or increase outward, leaving the observer in a unique position, meaning that we are the center. But the unwelcome supposition of a favored location must be avoided at all costs. meaning no matter what the evidence shows, they are going to manipulate it to make you think that we are not anything special. But yet, he's seeing through his telescope that we are special, that we are the center of the universe, that we are not on the far recesses of space, just floating around. Okay? What more evidence do you need? You already see how the science is manipulating it. And Edwin Hubble wrote it down in his own book. Ain't that something else? Ain't that something else? Excuse my French, but ain't that a bitch? Ain't that a bitch? Seeing the truth. And he's saying he's saying a central universe must be avoided at all costs. A favored location must be avoided at all costs. Meaning that mainstream people will never have the chance of seeing that we are truly the center and that we are special. Now let's go over to Dr. Sungenis and let him elaborate on this. Because this is just astounding. The evidence is just astounding. So why do we need to keep listening to scientists when Edwin Hubble says with his own mouth a favored location must be avoided at all costs? There's no reason to. They're always going to show a bias that they're always going to show this bias that just takes us away from being special, and they can manipulate the math to do it, as we saw what Lorenz did, with Albert Einstein did. 50 scientists, don't forget that, 50 scientists walked away when Albert Einstein came up with his special theory of relativity, because it was just nonsense. 50 scientists walked out. All I can say is praise Yah that we are getting this truth today. Praise Yah. And I hope this evidence so far is making you think differently. Praise Yah that you are watching this video and getting this information, and that you are learning the deception of these scientists. Now here we go.
When Edwin Hubble saw the galaxies with their redshift back in 1929, it was amazing to him because everyone expected the galaxies to have blue shifts and red shifts, not just red shifts. Now, red shifts, if you are familiar with the term, well, if you're not familiar with the term, is I can explain it very simply. Redshift is the tendency of the white light to go to the red end of the spectrum. And if it's going to the red end of the spectrum, let's say you see a rainbow, and the rainbow looks more red, the reds are more prominent than the other 6 colors. Well, what that means something. That would mean that the rainbow is actually moving away from you at a very high speed, and the wavelength of the light is being stretched, so you see more red than you would see blue or violet. And if that's the case, when you're looking at the galaxies, well, that means these galaxies are moving away from us, or the other possibility is that they're losing energy as the light is coming from the galaxies, and Hubble also admitted that. But let's just say it was that the galaxies are moving away from us. Well, if we look around us and in every direction we see red, a red shift, that means there's no blue shift. Well, that means we're in the center of the dispersion. We're in the center of the expansion. And Hubble saw this in his telescope, and he didn't know what to do with it, but he knew the implications of it. The implications of it were that the Earth is in the center of the universe. And he remarks in his book, the 1937 book called what's it called, the Observational Approach to Cosmology, on pages 50, 51, 52, 54, 60, and 63, that the option of having the Earth in the center of the universe is a horrible option. It is an option that we must avoid at all costs. It is an option that is intolerable. These are all his words that he uses in his book.
Very scientific words.
Yeah. And you're wondering, well, why the emotional reaction here? You know, what is it? I mean, aren't you a scientist? Shouldn't you be amazed at this kind of evidence if that's what you see in your telescope? Well, what it tells us is that Hubble, like everyone else, has a philosophical bias, and that is he doesn't want the universe to have a center point. He doesn't want the Earth to be in the center of the universe. And the reason why is this. Philosophically, if you have an Earth in the center of the universe and the whole universe is rotating around it, that means the Earth has the dominant position, but more so is that someone with a capital S had to put it there, because it's not going to happen by chance, you see. That's the implication of having the Earth in the center of the universe, and that's an implication that Hubble knew he could not accept. Now, going back to Stephen Hawking, in his book, A Brief History of Time, he's remarking about what Hubble saw in his telescope, and Hawking admits, he says, well, it is true. If you saw the galaxies all around you, and no matter what direction you looked, you saw them having a redshift, well, you would think, yes, that we're in the center of the universe, because you couldn't have a redshift in every quadrant of the sky if we weren't in the center. It just makes sense. So he says, but we can't accept that, okay? Now, we have these... But we can't accept that, okay? Now, we have these... And then he goes on to say, well, we have no scientific reason for not accepting it. And then he goes in the next paragraph and he says, well, here's the reason I can't accept it. He goes, because I want to be modest. I want to be modest. In other words, he's saying, if I allow the interpretation that puts the Earth in the center of the universe, well, that means I'm looking at the human race as some special creatures in the universe, and that's a prideful position. And so I don't want to be prideful. I want to be modest, so I'm going to take the Earth out of the center, and I'm going to try to figure out a way that I can interpret the redshift in these galaxies as something other than the Earth in the center of the universe. And what they came up with was what Hubble had suggested back in 1929. He said, well, if we do this, if we change the dynamics and the dimensions of space, and we make it as if it's a balloon, and we put ourselves, that is our galaxy, the Milky Way galaxy, on the surface of that balloon, and all the other galaxies on the surface of that balloon, so that there is no center. It's just a balloon surface, and you can do this with Riemann geometry, or they call it a hyperspace, where you can have the space curved in such a way where you just have a balloon surface with no with no central point and no substance beneath that surface. And so if we put all these galaxies on the surface and we blow up this balloon, just like you would blow up a balloon at a party, well, what happens to that balloon? Well, the balloon starts expanding, you see, and all the dots on that balloon, all the galaxies, so to speak, would be separating from each other by the same rate. He goes, so that's how I can explain away putting the Earth in the center. I'll just put the Earth on the surface of this balloon and we'll blow it up, and we'll call this the Big Bang expansion, you see, and that'll take the Earth out of the center. He goes, and now that's the explanation I prefer, but I don't have any scientific proof for it. I just prefer it because I want to be modest. Now I would come back and say, well, that's a feigning of modesty. That's a feigning of humility. It's not real humility. Real humility would be to say, if I find evidence that puts Earth in the center of the universe, well, that means that someone greater than me put it there, because I know it can't happen by chance. And if I really want to be humble, then I'll humble myself before that someone, with a capital S, and I'll submit to him. And I will try to find him. I will look at the universe in a totally different way now and see that it was put there by design, not by chance, you see. That's really being humble with the evidence. So I don't accept what Hawking says about being modest. That's just an escape hatch that he's created for himself.
You mentioned a second ago about the substance of space. What is the aether, if I'm pronouncing that correctly?
Yeah, ether.
Ether.
It's spelled in two different ways, E-T-H-E-R or A-E-T-H-E-R. This is a concept, it goes all the way back to the Greeks. The word atom comes from the Greeks. Atom means indivisible. They had a concept where you could keep cutting matter. Let's say you had a ruler 12 inches long, and you cut it in half to 6 inches, then you cut it in half again to 3, and then again to 1.5 inches. Well, theoretically, you could go down until you have this point of matter that there's no return, so to speak. You reach a point where the Greeks knew conceptually that there had to be the smallest substance that could not be divided again, and they called that the atom. They also had the concept of the ether. That is, though material objects have are composed of atoms that you reach a point where they're indivisible, so the space does also, and they called that the ether, where it reaches a point where you can't divide space anymore, and the ultimate particle, so to speak, would be an ether particle. So that concept is very old. It's an ancient concept, but it stuck around because philosophically and scientifically, it's hard to get away from, because you have to figure if I'm breathing air, for example, it's oxygen, nitrogen. As a matter of fact, most of it's nitrogen, about 78% nitrogen, 16% oxygen. You got a little argon in there, a little carbon dioxide. Okay, so you're picturing all these atoms in the air that you're breathing, but you can't see it, right? It's invisible, and yet you know all these elements are going in your lungs every time you take a breath. Well, the ancient Greeks and even modern scientists understood that, well, space has to have something to it. It has to have a substance to it, because philosophically, nothing cannot exist.
Yes.
there has, you have the Earth and the Moon. So what's between the Earth and the Moon? After you get out of the Earth's atmosphere, what's between the Earth and the Moon? Well, they used to call it a vacuum. There's no air up there, so it's a vacuum. If you open up a can up in outer space between the Earth and the Moon, all the air would be sucked up out of that can, because it would go into this void, whatever you want to call it, this vacuum. But since then, in quantum mechanics, they have found that the vacuum is not really a vacuum. It's actually filled with material substance. Although this material substance they have figured out is not in the realm of protons, neutrons, and electrons, where you're down to around 10 to the minus 13 centimeters in diameter. When you're talking about the vacuum material out in outer space, you're talking about stuff that's down to the 10 to the minus 33 centimeters. That's 20 orders of magnitude smaller than the electron. Okay?
Super, super, super small.
Super, super, super small. Yeah, I mean, it's so small that they give it a name. It's called the Planck dimensions.
Mm.
They have a Planck temperature, a Planck diameter, a Planck mass, and these are all very, very exorbitant figures that we're talking about here. But that's in the quantum vacuum now. So that's what they've discovered. So,
Well, my friends, I hope that this video has changed your thinking about everything you think you know, because it is not the truth. Math has been manipulated. The true evidence of science has been manipulated. It's all been to keep everything away from realizing, keeping people away, and future scientists, modern day scientists, away from realizing that we are truly the center. And the reason why I started with these early scientists, because these early scientists are the people who wrote the equations for our modern day scientists. They are the Our modern day scientists are looking back to Einstein. They're looking and they're using the Lorentz transform equation, like Dr. St. John has said. He let us know that every that the Lorentz transformation equation is in all the physics books, and it is used for everything dealing with motion. So if they are wrong, everything else after it is wrong. So that's why I had to start here. And this ain't even all of it. I'm only stopping this video now because we're running over 2 hours. So I'm going to make the second part probably tomorrow. But yeah, this last bit of information is going to be even more groundbreaking. You thought this was groundbreaking? Edwin Hubble admitting that he found that we are the center, and that the hypothesis is undeniable, but a favored position must be avoided at all costs. It only gets better. It only gets worse for them. Better for Bible people like me, but worse for people who don't want to believe in God. Worse for people who have these atheistic views. And worse for definitely the scientists who are trying to promote this Big Bang Theory. It only gets worse. So, shalom, my friends, and I hope we've learned a lot in this video here, because there's more information coming. And I'll see you in the next video.